All right, in this section, we're going to be talking about one of the biggest topics in Azure. One of the most important topics as well is Azure Active Directory. Now, Azure Active Directory is a lot of things. Primarily, it's Microsoft's identity as a service solution, which means that when you're developing your own applications, you do not need to develop your own user management system where people can enter user IDs and passwords and you have to then store those and allow them to change their password, etc. You can basically offload your account management system to Microsoft's Azure Active Directory and then integrate those SDKs into your application. And you get basically all these features for free. Now, Active Directory also integrates with your corporate Active Directory, and so you can do synchronization that enables single sign-on, that allows people who have corporate accounts to be able to use that same account for your mobile apps and for your apps on the web, etc. Now, Azure Active Directory, as you would imagine, it's just got a lot of features and services. Let's go over to the Pricing Details tab here. And we're going to see the comparison between the different plans. Now, Microsoft has a free plan for this, so you can very well create an Azure Active Directory account for free, attach it to your subscription, and you basically get a lot of user management, add, update, delete. Users can, up to 500,000 objects can basically use your Azure Active Directory, 10 apps per user, etc. Now, there are also basic and premium plans. We won't focus on the Office 365 for now, but basic and premium plans. What you probably need to understand for this exam and just in general is what you get when you upgrade to the premium account, because you're going to see questions on the exam and you're going to have to decide whether this can be done using the basic account, the free account, or whether the person has to upgrade to premium. So basic and premium users, there are basically reporting features, self-service password reset. Now that's a huge one where users can just go to a web page, you put their old password, set a new password, the forgot password functions, your company branding, any kind of logos, etc. on the logins. There's also a service level agreement that comes with the premium and basic. When we get into premium alone, which is not basic, then you've got the ability for them to do the password reset that synchronizes back to your Active Directory running on premises. So they can change their password in the cloud, and that changes their password within the corporate network. All right, so two-way synchronization between AD and Azure AD. Multi-factor authentication, so if you want people to have an app or receive an SMS code in order to log in. Automatic password rollover. Conditional access is great so that you can say that if somebody is using a device that you don't recognize, they have to provide multi-factor authentication, or if they're out of the country geographically, or if they're using their phone as opposed to their laptop. You can set different rules based on different properties of the user, device state, etc. So those are some of those premium features, and we're going to get some advanced features such as identity protection, privileged identity management. So if a super user or administrative user needs to go through extra hoops to log in versus a basic user, that's on the P2 plan. Okay, so basically I do recommend that you look at this feature, but in this section of the course we're going to go through a lot of these requirements as specified in the exam requirements, and we're going to look at Azure Active Directory. So we're moving on. We're going to talk about DNS services. If you don't know, DNS is the domain name service of the internet that allows you to translate custom domain names. Microsoft's classic is contoso.com. It can translate that classic domain name into an IP address. And there is one single authoritative server on the internet for each domain that's going to answer that question. And in this case, it'll be Microsoft's Azure DNS services when we set that up and register that. Now, we could go through the portal, just sort of fill in the blanks. It's not so hard to create a DNS zone. But in this video, we're going to use PowerShell to do the same thing because we need to mix it up every once in a while. So I'm going to go into the Cloud Shell and start PowerShell. Now, before we create our DNS zone, let's create a new resource group to host everything. So it's new -Azure RM resource group. We'll give our resource group a name. I'm going to call it DNS group. And we have to give it a location. And I'm going to put it in Canada East. That was quick. Now we're going to create an Azure DNS zone. So it's new Azure RM DNS zone. We have to give our DNS zone a name. Now, you can name it anything. It's a pretty good idea to name your DNS zone after the domain name that you're going to be including in it. So I have a domain called the azureguy.ca. I love collecting domains. And I'm going to create a DNS zone for that within Azure. We just created our DNS group. It's going to be called DNS group. Let's create the DNS zone. All right, so we should have a DNS zone now within the DNS group. You'll notice that Microsoft is letting me know, even in the results here, the name servers. So there are 4 name servers that we can assign to this DNS zone, which means we need to go into our domain registry. If we use a domain registry service, we're going to have to modify the domain registry service to update it with Microsoft's name servers as listed. And that way the internet will know that Microsoft Azure is the home of the answer to this question as to where to go when someone types in the azureguy.ca into their browser. We're going to do that later because first we're going to set up the zone, and when we're happy with it, then we'll switch over the name servers. Now I have a web app that I recently created. I'm going to pull it into frame here. And this is an Azure web app, and you can see it uses this sort of subdomain.azurewebsites.net format to access it. So what I'm going to want to do is I'm going to want to use my custom domain name to access that app. So Azure's given me an IP address that I can use to redirect my custom domain name, the azureguy.ca, to my web app. And in order to do that, I need to add records to my domain name zone. Now there are a number of different records. Some of them are for mail. Some of them are to securely identify that you own a domain. We're going to use what's called an A record. An A record in domain name parlance allows you to map the IP address to the domain name. There's also something called a CNAME record, which would allow us to map the domain name to another domain name. But we're going to use an A record. So in order to add to this zone, we're going to have to use the new Azure RM DNS record set. The domain that we want to map is called the www domain. Now this is the reason why many websites start their URL with www, because it's a host name within the DNS system. We want to have record type A. The zone name is the azureguy.ca. And here's the resource group name. Was DNS group. Now there's a thing called TTL, time to live, or time to live. Essentially, this is the amount of time that we recommend that other domain name servers cache or save this information. Okay, so if we're going to set up an A record, instead of having every single browser come and look up the answer every single millisecond, There are servers in between that can cache that information. So 3600 is a pretty standard value. This is measured in seconds, I believe. So this is an hour, right? 60 seconds and 60 minutes. So that's a 1 hour caching recommendation. Now the part that's tricky is we need to then pass in a record. So we're going to use a bracketing here, which allows us to call another commandlet. So the new Azure RM DNS record config. The tricky thing about here is if I make a typo, so new Azure RM DNS record config, and it takes in an IPv4 address. So let's get the IP address that Microsoft's offering to me. So I have to cut out the HTTP bits. Now I have to put this in quotations too. All right. So this should create an A record within our DNS zone, which will allow us basically to the zone to know what to do when it gets a request for www. It sends that request to this IP address. So that succeeded. We can see the correct IP address mapped to the zone as an A record. Now the next thing we can do, let's use PowerShell continuing. So I'm going to say get Azure RM DNS record set. So we'll just verify what records exist besides this A record, the Azure. Oh, this is called DNS group. So we've got an NS record, an SOA record, and an A record. There's 3 records. Obviously, the other 2 records were provided by Microsoft as defaults. Now, what we need to do is we need to remember earlier on Microsoft gave us the name servers. I'm actually going to copy .com, .net, .org, and .info. Wow, I didn't even realize till now that they put it across to 4 different top-level domains even. How's that for, high availability, right? So we're going to have to go to our domain name registrar and update that with these. I'm going to do at least 2, minimum of 2 name servers in order for this to be successfully delegated. So I'm going to pause the video and do that. All right, so I pasted all 4 name servers. This is Namecheap as my domain registrar. I pasted all 4 into the name service field, and now I need to save this. And that'll take a little while to update. So we're going to have to basically come back and update Azure with some new information once we've got this complete, but it'll take a little while. So in this section of the course, we're going to talk about load balancing. Now there are 2 kinds of load balancers within Microsoft Azure. The load balancer is called a level 4 load balancer, and there's another one called application gateway, which is a level 7 load balancer. Now these have got a lot of things in common, but there are some differences. In this video we'll talk about load balancing, and we'll talk about application gateway after that. Now what is load balancing? Now basically load balancing is the concept where you have traffic that is coming in from another source, so that in this case it could be the internet, or it could be from another application elsewhere within your Azure network. Traffic is trying to reach one server, but instead of having a single server doing all the work, you've decided to distribute the load across multiple servers, 2 or more servers doing the same job. The load balancer is what does the distribution to ensure that one server doesn't get overwhelmed with all of the traffic. Now in this case, the load balancer, which is the level 4, only makes those determinations based on 5 factors, which are the source IP and port, the destination IP and port, and the protocol. So based on those factors, it can decide which backend pool is going to be the one to send traffic to, and out of those it's going to use an algorithm to distribute the load based on some algorithmic way. Now that means that the load balancer is a fairly dumb device. There's not a lot of intelligence here. It really is just someone comes in the door, sends them to server 1, someone comes in the door, sends them to server 2, someone else comes in the door, sends them to server 3, and that's called a round robin algorithm. There are other ways of handling this. Now so that's one of the benefits of a load balancer, is it basically is able to distribute the traffic that would normally go to a single server into multiple servers. The other benefit is that it is able to detect if something goes wrong with any of these servers and basically drop it out of the rotation. So let's say at some point server 3 stops responding. We send it traffic, and then a timeout happens and it never returns with a response. We can then make the determination after 1 or 2 or more failings that server 3 is dead, and we can basically just cut it out and only send traffic to server 1 and 2. So not only does it distribute the traffic, but it also monitors the health of the recipients and can then cut them out of the rotation when they are no longer healthy. Okay, so that is the primary function of a load balancer. Go into Azure. Under networking, we can see that we have these options. Let's create ourselves a load balancer. Give it a name, AZSJD new LB, classic name for a load balancer. First decision that we have to make is whether it's a public or a private load balancer, external or internal. Now, a public load balancer has a public IP address and a public name. That means that it's addressable from the open internet. If we made it an internal load balancer, it has a private IP address, does not have a public IP address, and is absolutely not addressable from the open internet. Okay, so if we want a public load balancer, then we need to create a public IP address. So let's give the IP address a name, AZSJD new IP, and we just want a basic address. We do not need a static IP that never changes. We are fine with an IP that will occasionally change because we're going to use the name of the IP address, the domain name essentially, to address it, not the IP address itself. We can optionally choose an IPv6 address. Within Microsoft Azure, the load balancer is one of the few devices that supports IPv6. So if you have an application that you need to work over IPv6 and need an IPv6 address, then you are forced to put a load balancer in front of it. So even if there's only one virtual machine, you would put a load balancer in front of that to be able to create a v6 address. Then the load balancer is going to address translate from the v6 address of the load balancer into the private IP addresses of the machines behind. Use my usual subscription. I created a brand new resource group for this. I call this New York app. So I'm going to create this load balancer as the first resource inside of my New York app resource group, and let's leave it into East US 2. Now while we're waiting for that load balancer to be created, we did notice that Azure gave us the choice between a basic and a standard load balancer. Okay. Now their standard load balancer is a relatively new feature set within Azure, and basic is the default, but you can choose standard. Let's look at this web page that shows you the difference. So a basic load balancer supports up to 100 instances behind the scenes, whereas a standard one 10x's that to 1,000. Okay. By the way, this table formatting is a bit skewed, but that's not my fault. within the standard load balancer, we can address any virtual machine in a virtual network, and it could be a blend of virtual machines, availability sets, and VMSS scale sets. Whereas for the basic load balancer, you get the choice of a single availability set or a single virtual machine scale set. Okay. It does support HTTPS traffic in load balancing in terms of health probes. I guess if your web app or your website only supports HTTPS traffic, then you are forced to use a standard load balancer. It does have some additional stay alive options for the health probe. It supports the new availability zones. We haven't talked about that yet, but it's another way that applications can be distributed for a high availability scenario. Standard load balancers can support that. Basic load balancers cannot. We've got the ability of Azure Monitor, which is Microsoft's new monitoring dashboard. We can now pull in login events from this load balancer into that. Secure by default, so load balancers, basic load balancers are default open, and you would have to then set up your network security group to shut down traffic to load balancers, whereas you would need whitelisted. It needs to be whitelisted in order for traffic to come in. This is the new thing for a lot of resources, blocked by default, denied by default, as opposed to a few years ago when a lot of things were open by default. So we can sort of see on this type of page that there's some very advanced things in terms of different outbound rules, basically allowing traffic to be sent outbound based on IP addresses or public prefixes, etc. Okay, management operations are a lot quicker. There's an SLA. The SLA here, remember in virtual machines, the SLA is 2 or more virtual machines. 99.99%, whereas the SLA is on the load balancer itself here. Okay? And the pricing is more complex pricing, whereas basic load balancer is free. So you do have some decisions to make. It pretty much in a production environment, you probably want to pick the standard load balancer simply because it has an SLA, although you have to investigate the pricing for that. All right, so in this section, we're going to be talking about a tool called Azure Migrate. Now, Azure Migrate is a tool that allows you to analyze your on-premises virtual machines and your workloads and prepare yourself to migrate those virtual machines into Microsoft Azure. At the current time, this only supports VMware virtual machines. So let's go into the marketplace, say create a resource, and we're going to put the word migrate in here, and we'll see Azure Migrate comes up as the first result. What we're going to have to do is create a project. So all Azure Migrates start with creating a project. So I'm going to hit the create button. Now we need to give the project a name, so this is AZSJD new migrate. It's going to be on my pay-as-you-go subscription. We can choose to put this project into a resource group. I'm going to create a new resource group for that purpose. And we get to choose the geography here. Now, at the current time, the United States is the only geography that's supported for these types of projects. But keep in mind that this is just the project and not where you actually deploy the virtual machines in the end. So we're going to click Create. All right, so that was pretty quick. Now, when we get into this project right now, the project is pretty empty. First thing we need to do is we need to discover the VMware virtual machines running in our environment. So this discovery is actually a virtual appliance that you're going to download. It's a virtual machine, essentially, that you'll download and load into your current VMware environment. This virtual machine is going to basically discover the other virtual machines within your environment. Okay. Now there is a limit of 1,500 virtual machines that can be discovered by this appliance, and therefore 1,500 virtual machines that can be as part of this project. If you need to handle more than 1,500 virtual machines, you're going to need to split that up into multiple projects. So at this stage, you would download the OVA, Open Virtual Appliance format file, install that into your local environment, and basically allow it to create the steps required to migrate those virtual machines into your environment. Now, once the virtual appliance has done its work, it uploads its results back into this project, and basically then you can create an assessment. So you can choose which virtual machines you want to assess for Azure readiness and cost estimation. So not every workload is going to be able to be uploaded into Azure. We're going to have to determine which ports to open and other factors, and also be able to know what size of a virtual machine we need to create within Azure based on the historical usage of those virtual machines within the VMware. So the assessment is basically a whole combination of the steps you're going to need to take in order to migrate this group of machines into Azure. So you can create the group basically by selecting a number of virtual machines or selecting an existing group and say we want to assess the readiness of this to migrate into Azure. So in this section, we're going to be talking about Azure Site Recovery, particularly around migrations. I'm going to go into all servers and I'm going to say Site. You'll see that Recovery Services Vaults is one of the options, and so I'm going to select it. I don't currently have any Recovery Services Vaults. Now, Azure Site Recovery is, as the name implies, a disaster recovery tool. Now, if you've got a set of virtual machines either running in Azure or running on premises or external to Azure, you can use Azure Site Recovery to have basically a replicated version of your application, multiple virtual machines, and your data ready to go in case a disaster happens. So let's say you do have your on-premises VMs, and for whatever reason, your internet service provider fails and you no longer have connectivity to the internet. You can basically initiate the failover. If you've got your Azure Site Recovery running and already replicated, ready to go, you initiate the failover, and then you basically deploy your entire application into an Azure region and get that booted up, and then you've got your application with up-to-date data ready to go. Now, this is a manual failover, but it is something good to have in place in case of a disaster. And if you discover that your applications are no longer responsive and you are giving up hope on being able to fix it quickly, being able to turn on the failover and then within 15 or 20 minutes have it up and running again is a pretty good outcome. Okay, it's not instantaneous failover, but it is a short-term failover. Now, you can also use the same technology for migration. So the same process of replicating your Azure VMs or your on-premises VMs in this case, basically you can initiate the failover and have that replication live within an Azure region, and you can set that up as your primary application from that point forward. Okay, so initiation of a failover is basically what makes a disaster recovery situation into a migration. So we're going to go ahead and create our first Recovery Services Vault. Now, one thing to keep in mind for a Recovery Services Vault, especially when you're using it for emergency recoveries, is that you basically want the vault to be in a different region than you're basically going to replicate from. So let's say you've got US East region, US East 2. If your virtual machines are already in East US 2, then basically having your Recovery Services Vault and your virtual machines in the same region means that when the disaster strikes, that your vault is offline as well. So make sure that in the case of disaster recovery, that your Recovery Services Vault is in a different region. In the case of an on-premises migration, then I guess it doesn't matter. You may want to have your Recovery Services Vault physically close to your data centers so that the data doesn't have far to travel and presumably goes over the quickest path. So AZ SJD new ASR. That's going to create me a brand new recovery services vault. We're going to let that run. So let's talk about diagnostics within Azure. Now, certainly each of the resources that we've been working with has a diagnostics option. So this is a resource group, and I can go down and look at the diagnostic settings for the resources in this group, which is another great reasons we organize things into resource groups. Going back into it, we can choose our Azure web app, and again, going down into here, we can see that Azure web app does some stuff automatically, but we can right now all the diagnostics is turned off, and we can certainly start to turn on different diagnostic settings if we wanted to start tracking diagnostics from Azure web apps. Okay, going back up to here, if we go into the services and we start looking at Azure Monitor, right? So Azure Monitor is a relatively new dashboard for all of the diagnostics activities within your account. So monitor your applications and your infrastructure all in one place. So instead of it being so diverse across, even at the resource group level or into individual resources, we can look at metrics, we can look at logs, we can set up alerts, all within Azure Monitor. So Azure Monitor, very rightly, is starting to become the home for diagnostics. If we see down here, there is a diagnostics settings tab into Azure Monitor, and we're seeing the same resources that were shown in the diagnostic settings at the resource group level. So now it's all in one place for the same effect. Let's go over and look at a virtual machine. So here's a virtual machine that I created the other day. And you can see that does actually fire off CPU and network, etc. But if we go down to diagnostics settings, there's a diagnostic settings menu here. First of all, if you might have to turn on diagnostics. Okay, so it was something that I enabled when I was setting up the virtual machine. But when you go here to this overview screen, it might say, please turn on the diagnostics. And so there's an agent that needs to be installed. Let's switch over to the agent tab. So the virtual machine is actually modified in order to throw off diagnostic settings. So if you don't enable the agent, you don't get diagnostics at the Azure level. In order to have diagnostics, it needs a storage account. You can see here on the agent tab that the storage account has a 5 GB disk quota. So what that means is that as it's accumulating logs, it's going into a storage account, and that storage account is actually an additional thing outside of your virtual machine that could cost you money. Now, the cents per gigabyte isn't too bad, but 5 GB of storage being used, or 4 GB of storage being used, it's still money that you should account for, essentially, right? You can actually remove the diagnostics agent if it's giving you trouble. This is one of the things, if your diagnostics is not working, you can basically reinstall it. You can remove the agent and then come back here and it'll allow you to turn it back on. Okay, so we'll start off there. Now, there are a number of sets of diagnostics that your virtual machine produces. First off is the performance counters. So we saw on the overview screen, CPU, memory, disk, network. Like those are the sort of the basic set of performance counters. What that means is every 60 seconds in this configuration, every 60 seconds, your CPU is being tested, your memory is being tested, your disk and your network. Okay. So if we go back to a diagram like this, this is every 60 seconds. Every minute you can see as you move your mouse, the CPU has been tested. That means it's not actually being tested every second or in between times. Go back down to diagnostic settings. Okay. Now, if this is not, let's say you want more fine-grained or less fine-grained settings on this, you can certainly customize that. Okay. So if I said custom, then I can I can basically, there's 5 pages of performance settings. Okay, so if CPU doesn't even show up, well, processor, I guess it makes sense. So under processor information, we've got percent processor time, percent privilege time, percent user time, processor frequency. So we could sample this every 20 seconds if we really wanted to know what the processor is doing more frequently than every 60 seconds. We can disable some of these things. Again, this is all getting into our log file. This is all getting into our storage account. There's really no sense collecting things if you're never going to use them. So, sort of make some intelligent choices in terms of your custom settings, or you can just be happy with the basics. Hitting save is going to then have to go to the agent within your virtual machine and change how it sends agent stuff back to Azure. So those are the performance counters. We also have logs. So think of the Windows event log in your Windows system. It has application security system as 3 of the tabs. So you can basically equate this to the Windows event log, being able to have those events bubble up into Azure itself and then being able to monitor those types of events. You can see that if you want to log, if this is an IIS machine, you can collect your IIS logs and store that within Azure. Any sort of failed requests, etc. If you've got .NET applications and you want to get tracing output generated outside of your VM into Azure, you can enable that as well. Okay, so logs is pretty straightforward. Crash dumps is pretty self-explanatory. It's disabled by default. Are you really going to be investigating the contents of the memory? It's a very specific use case for you needing the contents of the memory when a process fails. If you're going to be able to have the technical capability to investigate that. Syncs are external services. So for instance, Application Insights is considered one. You can have your diagnostic data fed into Application Insights. So that's how you set up diagnostics for a virtual machine. If we head back to the Azure Monitor, I actually have a shortcut here. Head back to the Azure Monitor. We can see that it allows you to look at activities, alerts, metrics, logs. We're going to look into that in a future video. But what we're concerned with is the diagnostic settings for virtual machines. And we can see here that Azure Monitor has applications, virtual machines in preview mode, containers, and network, which is Network Watcher. So now, right now, if I click it, it's still collecting data. So we're going to let that run for a little bit, and we'll come back to that. But basically, as the virtual machine starts filling its logs, we're going to start to be able to look at the health and performance of that virtual machine, or all my virtual machines, using Azure Monitor. So in this section of the course, we're going to be talking about virtual networks. Virtual networks is worth 20 to 25% of the exam score. So it's about a quarter. Now, virtual networks are basically the glue that binds, virtual machines and resources such as that together. So networking is basically what ties all of your resources together. I'm going to go into all services. I'm going to type virtual network. And a few things come up. We're not talking about classic networks. We're just going to go into the virtual networks. You can see that I have 4 virtual networks on my test account right now. 2 of them happen to be named the same thing, but in different resource groups. So let's go into the first AZ101 virtual network. And we can see here that this virtual network is part of this resource group. I'm going to go in and see that we have 1 default subnet, and the address space for the subnet is 10.0.16.0 and takes up to 250 addresses. Actually, it's 255, but there are 5 that are reserved for internal use. Okay. So 250 available addresses. Now the first thing we're going to talk about is peerings. So if we go down into the settings here, I'm going to minimize this part of the window. Go into settings. We're going to see that there's a peerings section. Now a peering, it's kind of an odd word, but what it means is to connect two virtual networks together. That would mean that all of the resources on this virtual network, let's look at the connected devices. So there's a network interface card that's connected to this virtual network, and presumably there's a computer connected to this network interface card. Okay, so all of the resources on this virtual network would be able to access the resources in a connected network, and vice versa. All of those resources in that network will be able to access resources in this network. Now to add a peering, we go into settings, we say peerings, we say add, and we have to give it a name, so SJD new peer. We obviously want the resource manager model, we always do. Now this resource ID, it's good for when you have a virtual network that's in another account, another subscription. So if you do not have access to this within this subscription, but you have it in another subscription, you can put the resource ID in directly. But if it's in this subscription, I can just choose the subscription and I can choose from the list. This AZ101 VNet is the one that we're working on, so let's choose the other one. We're going to get an error message when we do this. The error message we get is that the IP address range of the second network is actually identical to the IP address range of this network we're working on. So this 10.0.16.0 exists in both networks, and so obviously you can't connect two networks together if the IP address ranges are the same. So we're going to have to basically create a new virtual network that does not use these IP address ranges so that they're unique between them. Now we're going to just change it to a different network. I'm going to choose AZ/SJD new VNet, and that uses a different IP address range and there's no conflict. Now remember we said that when we connect these two networks to each other, one of the things we can do optionally is to allow them to access each other's resources, and here's the switch enabled by default, or to disable virtual network access between them. This next option is called allow forwarded traffic. So if you think about the scenario where you have this network connected to another, and then you have that other network connected to a third network, well, can you travel from this network to the third network? Okay, they're not directly connected, but there's an in-between. Well, this forwarded traffic will allow the traffic coming from another network to pass through this network to go to another network. It's like three networks chained together. Allow gateway transit. So basically, if you have a VPN or a virtual network gateway installed on this network, do you allow the other network to access your gateway? Okay, so that's the allow others besides your network to access the gateway that's on your network. And then the opposite. So do you want to allow this network to access the gateways on other networks? Okay, and it's one or the other. And you can only allow the gateway transit if you have a gateway, obviously. And you can only enable this remote gateway if you don't have a gateway. So we've got this new peer that we're going to be created. We're going to enable access between them. And we're not going to set up any of these options. I'm just going to click OK. All right, so once we've done that, the peering is set up halfway. So the peering is set as initiated. What we need to do is now go over to the other resource and set up the peering in the other direction in order for it to be connected. So we're going to close this. We're going to go into virtual networks again. And I'm going to go over to the other network that we were setting up. We're going to go down to peerings, minimize that window, and say add AZ/SJD new peer. We're going to say Resource Manager Model. We're going to choose the 101 Resource Group Virtual Network. We're say it's enabled. We're not going to choose any of these and click OK. Now it says adding this peer. Going to leave this section, come back to it, and now the peer is connected. See, it was initiated before and it's connected because I've set it up in both directions. So now we have basically devices that are on each network now there's no devices on this one, but devices on each network could access each other because we've set up peering between the two networks. Now there is a definition. You will hear VNet to VNet peering. That's when two VNets are in the same region. And then the other one is global peering, and that is when the two virtual networks are not in the same region. Okay, process of setting them is the same, but you're just going to get a different set of performance criteria if they're in the same region versus they're in different regions. If two VNets are in the same region and you connect them, Microsoft claims that there is no performance hit, and basically the connections between the resources will appear as quick, with no lag time, as if they were on the same network. Obviously, in a global situation, you're encountering more hops. Data is traveling many hundreds of miles to get those between those resources, and you cannot say a global peering has the same performance. But within the same region, two resources on two different networks connected through peering should have this, unmeasurable lag time between them, the same as if it's connected on the same network. So we started off this topic of Azure Storage talking about storage accounts and particularly tables. Remember, we created a table, we then used a .NET application to insert data into it and then read data from it, which is structured data which is stored in a tabular format. We then talked about Cosmos DB, which is a NoSQL type database. You can use, it's multimodal, so you can basically choose which type of data you want, MongoDB, Cassandra, etc. We chose the SQL storage type, which is DocumentDB, JSON files essentially. We used .NET to read and write from that. Then we moved on to relational databases, which is primarily Azure SQL database within Azure, although not only does it have the SQL Server equivalent, it has PostgreSQL, MySQL, and MariaDB for Azure SQL as well. Now we're looping back to talk about storage accounts once again, and this time we're going to talk about blobs. Now storage accounts do support queues and files as well, but these are not listed as topics on the test, and so we're not going to dive deeply into them. But blobs are basically the ultimate in unstructured data. Blobs are basically just a container in which you can throw files. And so we go into here, blobs, we'll see that there are no containers to start. And we may want to just create ourselves a container. I'm going to call this first. Now, there are access levels in the container at the container level. So we can basically say, for private containers, they always require authentication to access. And then you can have blob containers, which basically allow for anonymous access to the individual files. You would use this for your website if you wanted to store the images and the text files and the videos in this container. That needs anonymous access, and you might want to create blob level anonymous access. Finally, container level anonymous access will allow you to actually access the whole container and list the files inside of it. So this is an additional level of anonymity. But let's go to create a default one, which is private, probably the best one for most circumstances. So we just created a container called first. Now, even using the portal, we can just upload a file into this first container. So I'm going to click the upload button, choose a file from my computer, and upload it into this brand new container. I'm just going to choose one of my course images here. And we can see here that it basically allows us to overwrite the image. We can set the authentication that we want to allow for it. Let's just leave all that and just say upload. It was only 200 kilobytes. It's uploaded successfully into our container. So as you can see, it's just going to be a file folder that we can upload. Now I should also point out that there is sort of the concept of a folder structure, but it's not a real folder structure. It's more of a virtual folder structure. So I can go back to upload and we'll choose another file here. And so I'm going to choose this file, random file on my computer, and go into the advanced section, and you'll see it says upload to folder. So now I can choose the folder images as an example. But again, containers don't have real folder structure. It's just going to basically virtually create this concept of an images. So if I did that, it said completed. Then I'm going to see this folder that's been created, and I can see that it contains an image. Okay. Now this can be done as well using the API or in other methods. You can simply prepend the name of the file with this images / and it will create a virtual container structure for it. Okay, so it looks and acts like a folder essentially. Now this is all well and good. We can put files in here, but the real purpose of this and the value of it is to be able to access those files when we need it.